We are going to solve this integral using integration by parts. So what I do is to do the DI method, D for differentiation and I for integration. I am going to differentiate the sine inverse of the tan hyperbolic function of x like this, and I'm going to integrate just e to the x. So integrating e to the x is e to the x. This is plus, next one is minus. So differentiating the sine inverse of the tan hyperbolic function of x. So when we differentiate the sine inverse of x, this is equal to 1 over the square root of 1 minus x squared. We know this. We are applying that same principle here. So if we are differentiating the sine inverse of the tan hyperbolic function of x, this is equal to, we have 1 all over the square root of 1 minus the tan hyperbolic square of x. Then we differentiate this one and multiply at the top, and that is going to be the secant hyperbolic square of x. So the derivative of this one is this. So I'm going to write that here, and then we apply integration by parts. So that is going to be the secant square hyperbolic divided by the square root of 1 minus the tan hyperbolic square of x, like this. Alright, so let me free up space here for our integration by parts. So after doing this, normally what we do, when we multiply diagonal terms, we are done with the integration. But when we multiply terms horizontally, we have to take the integral. Alright, so our integral I is equal to multiplying terms diagonally, that is going to be e to the x. And then we have the sine inverse of the tan hyperbolic function of x. So we have gotten the first term of our answer here. And now minus because of this. So we are going to have minus the integral because we are multiplying terms horizontally, and that is going to be e to the x. This is multiplied by secant hyperbolic square of x. This is divided by the square root of 1 minus the tangent hyperbolic square of x, and then dx. Okay, so this one we are done with the integration. Now the task is to evaluate this integral. So let me call that I1. Why not? So I1, I'm going to solve it in a different color here. So I1 is equal to the integral of e to the x, and this is secant hyperbolic square of x dx, and this is divided by the square root of 1 minus the tan hyperbolic square of x. So here we have to use an identity, right? An identity of hyperbolic functions. So secant hyperbolic square of x plus the tangent hyperbolic square of x, this one sums to 1. So that implies that the secant hyperbolic square of x is equals to 1 minus the tangent hyperbolic square of x. So that means if I take the square root on both sides, this one secant hyperbolic of x is equals to the square root of 1 minus the tangent hyperbolic square of x. So I'm going to replace this one with the secant hyperbolic of x. Right, so let's do that. So I1, so this one should be a yellow pen. I1 is equal to the integral of e to the x. This is multiplied by this is e to the x multiplied by secant hyperbolic square of x dx on top, and this is divided by the square root of that, which is the same as secant hyperbolic of x. So this is equal to the integral of e to the x. This is multiplied by secant hyperbolic of x dx, because this one is going to cancel 1 on top, leaving 1 at the top. Alright, so here this is what we have, and now we know that cosine hyperbolic of x is equal to e to the x plus e to the negative x, this one divided by 2. So secant hyperbolic of x is equal to 1 over the cosine hyperbolic of x, and this is equal to 2 over e to the x plus e to the negative x. That is just taking the reciprocal of that. So I am going to replace secant hyperbolic of x in the integral with what we have there. We have the integral of e to the x multiplied by secant hyperbolic of x, which I'm going to replace with this. So that is going to be 2 on top divided by e to the x plus e to the negative x dx. Okay, cool. So I1 here is equal to the integral of 2e to the x on top. This is divided by e to the x plus 1 over e to the x. That is e to the negative x. That is this guy. And this is equal to what? So this is equal to the integral of 2e to the x dx on top. This is divided by, this is e to the 2x now plus 1 all over e to the x. So multiply top and bottom by e to the x. So we'll do it here for you to see. So if we are going to do that, we have to multiply here by e to the x, and then we do the same thing to the bottom e to the x as well. So when we do that, the integral I1 is going to be equal to the integral of 2e to the 2x. That is, this and this will now combine to e to the 2x. This is divided by, this is going to cancel that beautifully, and now we are going to have 1 plus e to the 2x dx. Okay, so here now we are now going to do a substitution. So we are going to let u to be equal to 2 e to the 2x. So when we do this, that means that du is going to be equal to 2e to the 2x dx. So this is the derivative. So that means that 2e to the 2x dx on top, I'm going to replace that with du. And now the integral is looking like this. So we are going to have the integral. This is now du all over 1 plus u, like that. And that is equal to the ln of 1 plus u. But what is u? U is e to the 2x. So I1 here is going to be equal to the ln of e to the 2x plus 1. So this is I1. Now that we have I1, we can go back to I, and then we'll wrap up the integral. So I is that is this guy minus I1. So I is equal to e to the x, and then we have the sine inverse of the tan hyperbolic function of x minus I1. So we have I to be equal to e to the x, the sine inverse of the tan hyperbolic of x minus I1 is the ln of e to the 2x plus 1. We are done. We can put the constant of integration, and this one conforms with the answer that I gave in the beginning of the video, and that agrees with the answer that MIT gave for this integral. So that is exactly equal to this answer I provided in the beginning of the video. So that is how I solve this integral. If you find that helpful, consider subscribing to Calculus Diaries and give me a thumbs up, and then I will see you in the next one. Bye bye.